with the final stream for today, building a 2D game with Flutter from scratch. Over here you see what we have so far. We are rendering a player sprite with the pointing up, so that also takes the angle of the sprite into account. The goal for today is I want to finish implementing the game loop. We looked through the game loop in the last video that Flame has, and we'll basically take a lot of ideas from there, just to say the least. There are a lot of things in there that, as I said, are probably very well thought through, probably took a while to figure it out, and I'm not so familiar with the Flutter internals that I would know how to improve on that a lot. So we'll just use it as is. We'll remove the parts that we don't need, but mainly we'll just use them. So again, this one will be about an hour. I will stop at the top of the next hour, and then I will continue actually tomorrow night with the next episode on this. So what we had so far, we started looking through how the game widget gets created, and we didn't like that the game had some sort of thing on it to widget or get widget. So the way we're doing it, we have a game widget in a game, and so you create those separately. And actually, while we're talking about this, I'm actually going to move this out into a new file. I'm going to call it game widget, right? I mean, there's really little in the game file right now, but who knows? Things might get bigger actually. So we actually might be able to remove some things here. Let's see what we don't need. Yeah, that's what I thought. So we don't need anything related to material in this point. So put this in here. Obviously now I lost the embedded. Well, I lost everything. Okay, that wasn't good. What we'll do is just undo everything and copy that, and then put that in here before. Oops. Okay, that's odd. So go back here. Let's. Actually, clipboard is working oddly. It just didn't copy what I wanted to copy. So here you go. So now we got that in here. And the game obviously comes from our game file. Inside the game, we can now remove this and the stuff that we don't want in here. Okay. The other thing is that obviously the embedded game widget, we don't need. We will not use it in our game directly ever. This has just been public in case you wanted to use it directly, but we won't ever do that. We'll just use a game widget. No need to have that. So this way we can make it private. This kind of communicates how this is supposed to be used. And so now we're going to go through the game render box one by one. So the game render box is basically where all the magic happens. And in this case, we're actually going to take the game as an input. So I'm actually going to copy the class constructor here, or at least the declaration here. So it basically has a widget binding observer to get certain information about certain things happening in the during the game. I'm also going to make that private before I move on. And so when you create one, you basically give it the context, right, and in the game. So we need a final build context, and we need a final game. Okay, so we got that going on now. Still complaining. So we need to have a method body, it says, because we didn't rename that correctly. Okay, here we go. So and now we're going to implement all these little methods that it has. As I said, we're going to go step by step. So there's an override here. If you look at the overrides, so there are certain things that it's using. One is perform resize, which oddly enough is not, well, that's interesting. So how can we tell it to override from the render box? Just implement method maybe. I don't know. Okay. Okay, no, that's odd. It's not showing us the overrides of the render box, which is kind of not ideal. Okay, well, we'll fortunately we have the code over here. So one override that we have here is get a size by parent. Okay, and so size by parents we're going to say it's true. So meaning that we don't want to size ourselves. Our constraints are coming from the parent, which makes perfect sense. So then we're going to and we can see where that's coming from. That's actually coming from, let's see where it's coming from. If we click on here, that is coming. Wow, where is that coming from actually? Very low down in very low in Flutter. So we're getting deep into Flutter. So that's what I'm saying. We don't have to basically understand all of these things in order to implement this. Now, the other thing we're going to override is perform resize. And I don't like, you probably notice I don't like the overrides on top of it. I can easily see that in my IDE here, there's an override. I don't need that in my code additionally. So we call it super perform resize, and then basically we tell the game to resize. So that's important. So this happens basically, I don't understand. Okay, where does the size come from? So Flame actually uses the biggest constraints of this control. So basically the game render box takes the biggest constraint that it has and gives it to the game, so the game knows, oh, it can be this big, right? And that will then allow us to render to the canvas correctly, knowing its size and so on, right? If you need to resize tiles or whichever one. The other thing is important is attach and detach. So I keep doing the same mistake here. So attach basically allows us to know that when the widget attached to the widget tree, right? Basically when the widget is finally shown to the user as well. So then we can call game.onAttach. And as we said here, we don't do anything by default, but in the future we might. Like we might reload the model that we might have saved on detach and so on. So it's kind of useful. And the other thing that it actually does is, and we're going to get to that in a second, it implements, starts to schedule a tick, right? So it starts basically the game loop, which we're basically trying to implement here. That's the main reason why we implement this widget. And then it binds lifecycle listeners, which might be important. So we're going to look at that in a second. But let's just do detach first. And here basically we also tell the game to detach. All right, and basically it does the opposite of schedule and unscheduled listeners, right? So let's just start. Let's just start with the scheduled tick and unscheduled tick. That's basically what it does on attach, and it unschedules it on detach. So let's put it in here. And again, I'm basically just looking this up exactly from Flame, but I don't want to just copy it over because I want us to understand how it actually works and what it does. So let's see what it does here. I'm just going to actually copy that code because it's just one line. Frame callback ID. So we need to create one. Well, first of all, we need the... Okay, interesting. There are a bunch of things wrong here. So the tick. I don't even see that defined here. Let's see where it comes from. Okay, so tick is actually a callback. Okay, so let's forget about the tick for now. Let's just implement the framework callback ID, which is just an int, right? So So we got the frame callback ID. We assign that, and we basically only use that in the unscheduled tick, where we basically just do this. Okay, so let's import this. So the scheduler, so now we can actually look at what this actually does. We schedule a frame callback here, right? So schedule frame callback. Basically what it does, it says that anytime when a frame is scheduled, it calls us. So that means that this is basically the tick, right? And we're going to be called exactly with whatever the frame rate is. So if you're at 60 frames per second, we're going to get called 60 times a second. Now, obviously, in our callback, right, when our callback runs, it will run synchronously. So the stick method here will run synchronously. Now, obviously, if we take a bunch of time in there, just double check that my microphone's actually on. If we take a bunch of time in there, then we'll delay, right? Like basically, then the frame rate will go down, right? Because it's trying to tick, but every time, for each tick, it has to execute something. So if you have 60 frames per second, right? So you have 1,000 milliseconds, and you take that divided by 60, you get roughly 16 milliseconds to do your thing. If your code takes longer than 60 milliseconds, then basically your frame will go down, right? Now, another thing, so what we're going to do is obviously update and also render, right? So in the 60 milliseconds, we have to do all these things. Now here, basically, all this is doing, it cancels it. So we get an ID back, and then basically we'll just remove those from the callbacks. It's really that. It's kind of like you can think of it just a simple event emitter. And so now in the tick, what do we do in the tick? Now that's the fun part, right? So first of all, it's saying if you're not attached, then return. Okay. So where does not attached get set? Well, not attached gets set. Interesting. I don't know where. Oh, actually, that might be a global, like a base class variable. Oh, there you go. So there's a variable that's defined inside node abstract node. I mean, we're really, really low down here. But that's basically any node in the widget tree, I suppose, can be attached or not. So if you're not attached, then basically we return. Otherwise, we schedule a tick. Why do we do that? Well, because we're not setting an interval, right? So we have to reschedule the tick. So we got called here, right? Then we tick, and then it gets removed afterwards. So if you look at that, then basically when it ticks, it will basically remove us. So let's see, transient callbacks. We'd have to look at where this basically is all happening, but we can be pretty sure the way it's set up that after every tick, our callback gets removed, so we have to reschedule ourselves. It's kind of like a set timeout that you have to do over and over. And then we basically, so we get a timestamp here. I'm not sure if that is a DT or not, probably not. So what we do then, we update ourselves from the timestamp. Okay. And then we mark needs repaint. Okay, and we're going to look at all these methods in a second. And why this is a global, I'm not sure. So we'll make it actually a private, no global, public, right? So now we're going to look at the update method. So let's create that. All right, so in here, so the timestamp is basically right now. So it's not a duration, it's actually a timestamp, right? I mean, like it says now. Okay, so they call it now. I'm just going to actually name this to timestamp TS, right? And then, and so what we'll do is we compute the delta. Okay, so the delta, we need to compute that, So we need that function, right? So now we're starting to get into the meat here. So we compute the delta, and I kind of like the way this goes because we're slowly but surely understanding how this works. So we compute the delta. So the cool thing is that now we're actually realizing that maybe when we call update in our game, maybe we don't only want to give it the dt, the delta, right? Because I mentioned that with the multiplayer game, well, I mentioned that we are thinking of doing it as a multiplayer game, and I know for a fact that in that case it actually is important to know the timestamps of things when we send updates to the server. So Flame by itself, as you can see here, it doesn't include this information in the DT, in the update. So what we might do is we might include the timestamp here. Optionally. Well, actually, it won't be optionally, but yeah. So we'll just do it like this. It can't be optional. We'll always pass it. So we do but the thing is that the duration is basically just another way to give it milliseconds, right? So we could also just give it milliseconds or microseconds, right? So actually what we're going to look at is we're going to look at how time since last epoch or something like that. So epoch, I want to see like what resolution that is. So it says seconds. That's not going to be good enough. So we need actually milliseconds, at least. Actually, milliseconds is fine. We don't need more than that. So actually what we're going to do is we're going to not have duration here. We're going to have double. We're going to have a timestamp in MS. Right? We can do it. Well, we don't want a huge thing. It's called timestamp, and we're going to document that the timestamp is in DT. I think DT is seconds. So that's the other thing this is all in seconds, and we actually might want to switch to milliseconds. So in Flame, they're actually passing the DT in seconds with a fraction. We might just almost like make it milliseconds with a fraction, and it's almost like to the point where we may not even need the fraction. But for now, we'll just do that. So basically, you say dt delta time since last update in milliseconds, and then ts is time since last epoch in milliseconds. The thing is, we might. So let's complain about here. Okay. The thing is, we might later on decide to actually make this since game start, but we'll see. It's probably easier to do it the way we have it. So then we can compute the delta. But the thing is that, so we update TS, and we can actually say, already give it in milliseconds, and now we are here in milliseconds already. And then here we also in milliseconds. Unless you need this. Okay, so let's see how they calculate. So they compute the delta, the previous. Okay, so I have a previous, and that is the duration that they set to 0. We're going to work with Flame. So we don't really need this to be like that, and we don't need it to be that, and so we can just say we started at 0, right? What's wrong here? Oh, that's not cool. That's not cool. So we want microsecond. You want microsecond resolution. So what we'll do is we make it into double. Basically, we're giving us the microseconds. Right, and then so also if you go to the game, you're gonna say with microsecond resolution, right? Okay. So here now we get timestamp. We get it here as well. So what were we looking at first? We wanted to see so I'm actually going to see like some. There was some way to hide the player, so I'm going to hide the player because I think it's maybe causing some problems with the internet. Okay. So now we have update. So we have to do the compute delta first. Okay, fine. So the compute delta, basically what do you do is the delta equals the current timestamp minus the previous timestamp, obviously. And then but the thing is that they also say that if basically previous, if it's 0, then it's actually 0. Otherwise, right? Which in a way doesn't make much sense. It's just like a weird like it only happens the very first time. So instead of saying my delta is whatever the timestamp is, well, actually does make sense. So the delta is 0, and then basically you assign previous to the current timestamp, and then you return delta, I think. And actually what they do, so then yeah, they return the delta. And so that's actually when then they compute it to a double. And they're doing it in an interesting way where I'm just seeing they do duration dot millisecond, I'm going to say milliseconds, microseconds per milliseconds. Right, so to make sure, I mean, there should be 183, 1000, yeah, like I had it, but okay, a little more clear that way. So now what we do is, in the update actually, we compute the delta first. The delta time is compute delta from our timestamp, and then we update the game with it, and we also pass the timestamp. So that should give it a little more information should we need to. Also, there's a record DT that they call in the game, which is actually calling a private method on the game, and that's just for debugging purposes, and we leave that out. So now we got the update timestamp done. Now we need the mark needs repaint, and that is actually part of the object. So this actually, I don't understand why it's not. Maybe I'm just mark needs paint. Ah, okay. So that's actually part of the total base of Flutter. Okay, so now so what's happening now is this. So when we attach, we schedule a tick, right? And then we tick, and then right. If you're not attached, then we return. In case like between scheduling it and receiving it, we get disattached, or detached. We handle that, and then we schedule the tick again to be called again here. So that's that part. And now we update the game basically, and then we tell Flutter that we need to be repainted. So that basically we update everything, and then we render everything. Let's see if like the render actually. Oh, see, the thing is like the render doesn't get called yet. So in that tick, we just do all the updates. Then we tell Flutter that, oh, we need to repaint, and I bet you in the paint that's when we're actually going to do the. That's when we actually get to do our rendering. So keeping the non-private method on top. Now we're actually ready to do the paint. So I think paint is an override. So there you go. So we do not call the super, which is interesting. So what does the super actually do? Nothing. Okay, that's fine. So it wouldn't hurt anything, but it's also not needed. So what do we do now? There's actually something interesting in here. I'm going to show you this. I don't know why this is actually needed. The game builder.offset. What I don't understand is like if we call the builder, so the offset here is 0. I'm not sure where the offset is being set. It's not set anywhere. Someone else is setting it. Let's see. Maybe the offset is set somewhere. Okay, so it's not set inflate. That doesn't seem to be related. Yeah, so I think the offset will always be 0. So that's why this code here doesn't really make any sense. We don't need that. But we need the game render. Okay, so that's the only thing that we want to actually do here. And the commas are in the context actually. So let's look at the painting content, what that actually is. So okay, what else does it have except the commas? So there's a little more information, estimated bounds. It's basically a canvas wrapper that does a little more things here. Yeah, okay, fine. So we do the render, and I think this is probably all we need, because well, there's a bind lifecycle, listeners. So we don't care for it on the game, but we might care for it. I'm just going to put this in here. We might care for it on the might be important here. Again, I'm not. So we could probably I don't know what this does. Okay. So maybe it's telling you, hey, I'm observing things. Let me know. I want to know. Just leave that. We leave that at this for now. We don't have to understand Flutter in its entirety. So on attach, actually, that's when it gets actually invoked. And a detach, it's unbound. Okay, unbind. Okay, fine. So now we pretty much have things working. So here, okay, width and height. Okay, right? Okay, so I think we're pretty good at this point. So what I actually want to do before we do anything more, this thing still should work at this point. What I actually wanted to see is if it works inside the browser. So what we'll do is we'll just stop this for now, and we'll actually run this in Chrome. Let's see what happens. Because before we change this all, I want to see if it worked before in the browser, and maybe it broke then, or maybe it just doesn't work ever. So we don't need the override here, by the way. Okay, so now it's launching our game in the browser. Oops, wow, okay. Working in the browser, that's pretty cool. So if this keeps working like this, what I can do is I can keep building this for the browser, and I can basically post this in, I can post this, on the GitHub Pages branch, so people can actually play with the game as we're developing it. So that's really cool. So we know that it's still working, and now we're actually going to convert this into a, make this the game, right? So what we'll do, so we have the engine here, we actually create a new folder, the game, and in there we have, surprise, surprise, we have a game. But actually we just call it, don't want to just call it game because we already have a game. Alright, so it's called Batufo game, and it extends the game. Alright, game we import. Alright, and now we can overwrite. Okay, so alright, so in first of all, obviously you can see here that whatever we passed to our widgets, we need to now pass to the game. So in this case, it's actually, we just need the game model, right? And we don't need to pass the sprite because now we will have a game loop. So the issue that we had before, that the sprite was rendered and then wasn't rendered anymore, we don't have that. Like it was rendered in, before it was ready, and then it was never rendered again. We don't have that problem. So so we have the game model. So that's what we need to pass to our game. Right. So we have the initial game model, and actually we will keep the game model state here. I've been thinking about this long, but basically the problem with keeping it somewhere else is you always have these set, get, game model things. But there will be one owner of the game model, and it will be the game. And it will basically call update on everyone, and they will each update part of the game model. And then the game model will, inside this update method here, will kind of merge the what needs to be like basically create this game model from it. So we have a game model, and right now we don't update anything yet, right? When we render, that's when it gets interesting. So Resize, let me actually look at what I used to do in Resize here. Basically, I just stored the size, and then you need this for the camera and stuff. So we'll just store it in a size for now. All right. And then in the render, that's where it gets interesting, because now basically we will render our player, but we won't just stuff that right into the game. What we'll do is we'll do player, and the player will have an update method for now, it only needs dt, and it will also have a render method. All right. So again, we're only using whatever, implementing whatever we need, right? So then the game, all it will do in the update method, it will say, well, the player model. Okay, well, first of all, so the thing is, for now we give it the player model, but if the player ever needs more things to do an update, that's fine, right? That's kind of the freedom that we have. Right? So import that, and so basically we will modify the player model in here maybe, and then when it renders, it also will pass the player model, right? And to be consistent, we just called model everywhere, and if there are more models that are passed in, then we name them. So the player model is basically the player updating the player model. So in here, well, first of all, we need to final player, and then basically player is a player, and it doesn't get anything yet. It doesn't render anything, nothing. It doesn't update yet, so we don't need to pass it anything. And actually, when we update, though, it's going to return us a player model. If it later on will affect more things, which is kind of not clean anyways, then we can implement that. But right now, it's just going to turn the model as is. All right. So now we're going to say player model equals. So in here, when we update, right? So we have the game model here. So we are the owner. So we don't get that passed into us. So what we'll do is we'll say player model is player.update. We have it with underscores, private update, and we give it the game model, player model, right? And I'm just going to go and turn on the light a little bit. It's getting dark in here. All right, so we are passing that in, but we need also the time passed, right? So now what we'll do at the very end, for now, really simple, we just set the game model dot player equals player model. And you can see the problem. You can't set it because it's final. Well, the thing is, at some point we wanted to have it kind of immutable. So that's obviously an option. For now, we'll not do that. So you can do a copy with, and you can create a copy of everything. But the thing is that most likely we will just send things to the server. So we don't, or if you just have a client side thing, and maybe you want to be able to replay things, right? Maybe you want to have a way to say, hey, you won, you did something great, you want to replay. So then you need to store all the game models. You need to store copies of them. You can't mutate anything, right? But if you're already converting things to JSON anyways to send it to the server or whichever format, then it makes no sense to have something immutable. It's actually much easier to work with if you're disciplined, right? And the thing is, in this case here, I'm the only person working on this, and I know that I'm going to be responsible, hopefully. So it's kind of overkill to have things immutable in this case, right? So now the update is basically done. And then in the render method, we do basically the same thing that we did in the player render. So when you render the player, right, so we draw the player, let's just basically copy that entirely, that method. But the thing is that actually we don't want to have that here, right, because we actually want that here in the render. So let's see. So we have the player already. Or maybe we can just call the player. Okay, so we have the player type position, the world position from stuff to do that. And we do all this stuff. And so then we need to create a player sprite. So we have to look at how we did create that player sprite. So the player sprite basically, okay, so what we do is here we create this guy and we give it the tile size. And we will name it so it's obvious, right? And then basically we have the sprite. We have a sprite here, but it's not going to be final actually. So see, it comes from our engine, and then we basically say the sprite equals sprite, and we don't have to use the from image thing anymore because it's going to be just fine. So we have the tile size. Let's see, what else do we need? Well, we need the path, and then we need the width and the height. Width is that, and the height is that as well. And in a way, well, some sprites might have different sizes. So, okay, and then we also need to just pass the path to the player, right? And so what I actually want to do is, I want in the game props, I want to basically store these function. So let's do a I don't want to have this repeated all over the place, and I want to have it in a central I want to have it in a central place where I can easily see it and change it. So let me go in here, take this guy out and put that here. All right, okay, cool. So, and then basically the assets, really part it here. Let's see if it's gonna complain. No, that doesn't work. Can I have an internal class? No, I can't. Okay, I would like to have this like a... I know how to do it. I'll do a getter. It's complaining. Okay. That works somehow. Wonder what happens if I do return type. Type. I don't think that will work as I want it to work. Let's do this out here. I don't think this will work the way that I think it will work. Game props dot assets dot. Yeah, there's no such thing as player on it. Yeah. Okay. So in this case, what we'll do is we'll not make it static. Right? We'll just basically doesn't hurt to have it like this. I just want to be able to say game props dot assets and then player, right? So but the thing is that the player itself probably shouldn't know about where this all comes from. It should probably know should probably get this from here. Final string final string asset or like to say image path, right? So then it's gonna get this from here, this dot image path. All right, and then well, actually we don't even need this to be a field. right? We can just do this. Sprite from image path. Okay, cool. All right. So then we have the sprite. And just player sprite. So now we have this. Now we just need to see what's in offset. Okay, and then circle pane. We don't need that. So basically, this is when we. Let's forget about this for now. This would only be important when we're debugging. So we render, we save the transverse, blah blah. Right. Now the other thing that we still need to do is we need to also lower left the canvas. So we pull this into our game. Basically here we first put the canvas in the right place. And so we need the height. Kind of want to pass it in here though. Well, actually, the size of the game gives us a height. Okay. So now then we render the player and the game model player. And the thing, since everything is called without model, we also name this game. Right? So that's the game model. And let's just make it private, just to make sure no one can mess with it here outside of our game. All right. So now the player is saying it wants things. It wants what? It wants the image path. Right. So what we actually want to do is we want to create the player. Hold on. Actually, it needs to be the tile size, right? So basically, what I actually want to do is I want to not refer to all these game props like statically like this, or maybe I'll just do it only here, right? So what we'll do is we say final double tile size, right? So we assign that. So we say tile size equals game props dot tile size. Not sure why this is not working. It should. Okay, I need to input this. So now we're going to input the player. We're also going to use player size as the tile size. And then basically what we're also going to do, we're going to say game props dot assets dot player. All right. That makes sense, right? So we have our player. Obviously now we might have to recreate it when this size changes, but the tile size doesn't change. So basically when our canvas size changes, we just see less or more of the canvas, but the tiles will still stay the same size. So we get our player, we can render it now, and then it says tile size isn't used, which is fine. So let's just not have it for now then. And then the player is doing the right thing, saves the canvas, does its thing, rotates, and then restores the canvas. And we don't want that circle for now. We only use it if we ever need to debug things, but actually then we use something else. So in this case now, we don't need any of this stuff anymore. The only thing that we may want to keep, which was actually really useful, is we may want to keep drawing the grid. So actually I'm going to make this wonder if this belongs to the engine, because there's clearly a helper, but it's fine. We'll just put it here. So we'll just call it grid. So we have a class grid. So we have the draw grid, and that's basically happens on the render. And we need the size. So this is interesting, right? So this one needs the size, so we'll need to pass it in. And when we get created, we want to take the tile size. Right. Okay. Make private, just to be correct. So at this point we should be fine, and then we just need to get that grid paint from somewhere. So we have paint, final grid paint. And then we need some more things. So we make this explicit because, no, we do see, that's the thing. We don't want that. We don't want all this stuff from here. So we want colors. The colors we want. And we painting style. Otherwise it will get confused again about the different types. So, okay. So a grid paint is paint, blah blah. Fine, we got all this. So now we render. We just want the size. And then we're all happy, right? So now in the game, we can actually say player. No, we actually want to say the grid, right? We could with the grid. So final grid. And we may turn rendering the grid off real easily, but at least now we have it in a separate file. All this code is hidden. Grid. And what does it want? It wants a time size, right? Improve, so tile size. Okay, so we got the grid. We need to import it. All right. So now we can say in here we also want to render the grid, and you see like how we render it before the player. Now what do we want here? We want the size, right? We render it before the player, so the player will show up top of the grid, right? So it's a simple like drawing operation, right? We just render one of the other, and they're all going to be on top of each other in the order that they were rendered. Okay, so so we're almost coming up on time. I hope we can get it to work. Because then basically what we'll do here, all we have to do is change the angle, and then the player will turn. So all this stuff can basically go away. We don't need the player spread anymore. We need the time map. We need the game model. And then basically the app will just have the game model as an input. Right? And then when we build it, set up all this stuff, and so what we'll do is, actually we don't need the game model even, we need the game. So final game equals but I'm kind of not so happy about the name now. So what does it need? It wants a game model, and that's it. Okay, so the game, and so basically what you're doing, we have the but game, right? So we pass the game. All right. And now when we render, we will most likely add more, like a scaffold or something, right? But for now what you're going to do is you're going to add a game widget, and we're just going to pass it the game. And that should be it, and then we don't need any of this stuff anymore. And let's see how this works. Try it first in macOS. Let's see if we get the result we want. We have a few minutes left. If you did everything right, it should work. I kind of doubt this though. It never works. But I would be pleasantly surprised. Let's just put it that way. And we got about 5 minutes left. Oh my god, we actually rendered a player. That is fairly unbelievable. And the main reason why we don't see anything is because our background color did not apply. That's pretty much it. Only the background color. So let's see if we can fix that. It's part of the game widget, right? If we can't figure that out right now, that's not a big deal. Oh, but we made it. Oh yes, so we made it basically transparent, right? So all we do for now, really simple. We'll just wrap this one in a container with a background with a color. So we're gonna say color colors dot something teal. See? Okay, good. Oh wow, that was pretty good. So now what should happen if we actually did this right? Then we would be able to just make this player spin simply by setting let's just say whatever dt is. So we need to really think about making some of this. Maybe it will be immutable, but that's fine. So for now, well, the thing is, are we taking the angle into account though? Yes, we are. Okay. Not spinning. Are we doing the update? Well, I'm going to say this. I'm promising that we will have the spinning before finishing this this episode. Game mode players, player model. Okay, so we are changing it. I'm going to put a debug burnt in here. First of all, to make sure that we actually get called. And second of all, to look at what the game will look like, how the game model changed. Yeah, so we're not ticking at all. We're not ticking. So our game widget is not calling game update at all. Are we actually getting here? So let's launch this in debug mode. Maybe we're missing something here. Actually, there's no point in not. Okay, we're not ticking. So the scheduled tick somehow didn't fire, I think. I don't think we're ticking. Yeah, we're not ticking. Okay, we'll figure that out. But one thing I wanted to do first, which got me a little bit annoyed, we already have a container here, so we can just easily say final color background or something, and when we build it, we say this dot background equals, and so right. So then it's off. Now we can pass this in. Okay. No game. We initialize the game. We don't have to do this thing, so we can remove this. And it should still work. So the only thing is, like, I don't understand why we are not Why we are not taking, so building it, pausing the game. I mean, we're rendering it. At some point we are rendering. We're calling game.render, otherwise we wouldn't see anything. So I mean, just for sanity, right? So I'm just gonna launch this. In this case, basically we have this option here to overwrite on attach. And we're actually going to put something in here. Let's call super. We don't want this from Cupertino. Oh my god, we want this from just foundation. Okay. And then we say debug print game attached, and here we say game detached, and we can actually see that yes, our thing got actually called. Otherwise, we wouldn't. But like, when we removed, so the paint is getting called. So now we can see what if we're saying game attached, game detached, game attached. So actually getting this thing, and so I'm not entirely sure why when we schedule the tick. And also it's black again. Why the world is it black again? Oh, because we're not passing that in. So we need to say background colors dot teal accent. Okay. Now we should get a teal accent again. Okay, fine. So we have that. Schedule tick. All right, we're scheduling a tick. In attached. Let's see if they're doing something different here. Not really. So I'm not fully sure why we're not getting a tick. Or maybe we are, we're just not. Well, but we had a breakpoint in there, right? We didn't get. But it will, I'll put a tick in something in the tick. If attached, if not attached, it should have been. Well, it's spinning. It's spinning so fast that it's hard to see anything. So we just need to change the spin speed, and then we get something. Let's say. Okay, now we go. We have a spinning player. We succeeded. So this means now that we have a game loop. We can update the models, and we render them repeatedly. So that's the first step. So what we'll do next, we'll see if this still works in Chrome, which would be awesome, because then I will just build it after we are done with this and post it. And we can basically keep this up, and people can actually interact with the game. Right now there's not much to do, but I think we pretty much got the main boilerplate out of the way. We got us a game loop. We're able to load sprites, images. And now we'll see if this works in the browser. Okay, see. Okay, good. It works in the browser still. So you can take that and show that to people and say, wow, I got a Flutter game almost working in the browser. So obviously here we got a bunch of debug prints going on now. I think this one here is the one that's causing a bunch of issues, or like a bunch of prints. But you can see that we are actually changing the angle. Beautiful. All right, so which means I can now also stop the stream. I will be back, and hopefully it won't be that dark. I'll try to find a better way to light at the place. But I will be back tomorrow. I will basically just tweet right before, like maybe half an hour before. Most likely it will be tomorrow at 7 at night. And I'll probably stream for an hour or something like that. So I hope you enjoyed it. Goodbye.